Okay, all right. So today what we're going to talk about is toward really at the end of the unit, all right? And there's two things left we have to talk about. One is standard deviation, which is today's topic, perhaps tomorrow also. And the next topic is constructing box and whisker plots, okay? And what the numbers mean. So let's get started on standard deviation and let's go. Okay, all right. So today, what we're doing is it's almost like the opposite of what we've been doing for the past couple of days, right? So last couple of days, we're talking about the measures of central tendency, right? So for example, like this was it. Nope, not this, right? Measures of central tendency, which kind of tells you how the numbers are lumped together in the towards the middle of a distribution, all right, so to speak. So today we're going to talk about the opposite, which is not how numbers are lumped together, but how they're spread out. So whereas mean median mode, where's my pen? All right. So whereas mean median mode, something's wrong here. All right. Whereas mean median mode talks about, okay, what's going on here? Hold on. All right, my drawing tablet's very glitchy, so I'm gonna write as little as I can then. All right, so whereas mean median mode talks about how numbers concentrate, all right, think about that. Data spread tells you just how far are the numbers stretched apart in any set of data. All right, so if you have a set of numbers, right, it tells you how far the data is spread apart. So how do we measure how data is spread apart? We use something called the standard deviation, all right, as a statistical tool. Now, what is the standard deviation officially speaking? All right, standard deviation measures the average distance of a data from the mean. So one of the things that I would like you to know then is that the mean is usually right in the middle of this bell curve, which is not new, hopefully, by now, right? Because I've been using bell curves a lot in class, okay? So I'll give an example. Again, all right, one of the topics I actually know a couple of things about, right? So let's say IQ, right? So if you look at an IQ score, 100 is the average, all right? And actually, let me use the curve below that. This is easier, right? So the average IQ across the world, all right, is 100. Now, this number gets adjusted, every now and then. So, but the standard that they wanted to use was that. Okay, so let's say the average IQ score, right, it's 100. And so what they're saying is, all right, and I'm going to teach you how to read this on a bell curve. What they're saying is one standard deviation, but that's the symbol for standard deviation. Okay, I'm not doing a very good job writing it. Maybe I'll insert a symbol in here. One standard deviation is 15 points. 15 points in IQ, right? So meaning one bar over, the person would have 115 for IQ score, and then another bar over, another one standard deviation over, the person here would have a score of 130. All right, if we go into the other direction, right here, one standard deviation below the mean. By the way I'm talking about it now is how people say it, okay? So one standard deviation below the mean. Let me use a highlighter. Yeah, wow, the writing tablet is very glitchy right now. There's something wrong with it. Okay, so one standard deviation below it's 85, and then another one more standard deviation below would be a 70. Okay, so here, now, so for example, I don't know if you guys have ever heard of this organization called Mensa. So it's an organization where people have to have a minimum of 132 IQ to be admitted into the organization. So it's like an organization for like people with high IQ, and then they meet once a month and they hang out, talk about stuff, right? So that would be somewhere right here. So in order to make it to Mensa, it would have to be 2 standard deviations, right? One, two standard deviations above the mean, which is 100, for you to be admitted as a member of the club. Okay, so that's one way to talk about distribution and standard deviation. Okay, but I'm trying to do this because I want to give you examples in real life so that I could get the concept across. So let's look at it another way. Let me draw another curve. All right, I don't think I'm going to do a very good job of doing it. So I'll give you a conversation that I actually had with Miss Berner a few years ago. Okay, so a few years ago, my incoming 7th grade class, all right, the students' grades were a little bit all over the place. Meaning I have students who are like, you know, who are getting 100 on every test, and then I had like students who were struggling, let's say, right? Now, no one was getting a 0, but just trying to make a point, all right? And so what happened, let's say this is the mean, all right? And, you know, this is not the most accurate graph, okay? So let's say the mean in the class was, let's say it's like 80, all right? So the curve is already kind of like messed up already, all right? And so I said, you know, I got to tell you, I think the students' grades this year are a little bit all over the place. Whereas in the past, the grades tend to lump together in the same place. So I'll give an example. So the year before, all right, I'm making the year up because I actually don't remember. So let's say for the year 2014, 2015, the prior year, the standard deviation was, let's say, like, I don't know, 6 points, all right? Which means the average distance from each of these markers to the mean was 6 points, all right? And I said, okay, when I spoke to Miss Berner, I said, and I can prove it that their grades are a little bit all over the place because the standard deviation now, it's about, again, I'm not 100% sure what the figures are anymore because that happened a long time ago. It's 9 points. So as a result, the data is more spread out, right? The distance from one standard deviation to the mean is wider. So one of the things I want to tell you is then, the higher the standard deviation, the wider the bars actually become. Okay, so these bars, instead of looking like this, the higher the standard deviation, the more they'll stretch out, like more like that instead. Okay, whereas things with very low standard deviation, it's a very tightly lumped together sort of curve. Okay, so that's what I'm trying to get across today. All right, and so then now that begs the question. Okay, again, you know, I know I'm trying to do my best job explaining this, but it's such an advanced topic, you know, at the high school and college level, that I'm trying to give you like the most basic explanation of it. All right, now that leads us to this, right? How do you calculate this on TI-84? Okay, so let me start my calculator. How are we doing on time? I feel I'm going over time already. It's okay. All right, let me do one example with you guys, and then we'll just do the rest in class. Okay, so here I got my TI-84. I'm going to enter in the data, so I'm just going to do one. All right, So question number 1. So I need to find the standard deviation of 4, 6, 6, 13, 11. All right, so let me go to stat. All right, edit. What are the numbers again? By the way, I gotta make sure the mode, the diagnostics is on. Of course it's not. Turn it on. Stat. Let's see, 4, 6, 6, 13, 11. Let's see, 4, 6, 6, 13, 11. Double check. How many times do I have to check that? Okay, all right. Stat, calc, one variable stat, enter, calculate. All right. Now, here, you actually see it already. Okay. So, hold on. I gotta double check something. Hold on. Okay, all right, back in business. So let's see. Yep, it's right here. This one, right, with this symbol, remember that? So that's 3.0, 3.405. 3.405. My pen is not working. Right here, 3.405, right? Okay, let's do one more, yeah? Let's try this one. 3, 4, 10, 14, 14. Okay, all right. Let's see. So let's go to stat. Oh man, my computer is freezing up. What's happening? All right, back in business. All right, let's edit the table by clearing it. Enter. What are the numbers again? Let's see, 3, 4, 10, 14, 14. Okay, all right, 3, 4, 10, 14, 14. So 3, 4, 10, 10, 14, 14, right? Stat. One variable statistics, calculate, and it is 4 points. So again, I'm looking right here, 4.73. Okay, 4.73, there we go. All right, the pen is stuck, so it's choice B. Okay, let me just, I just want to double check something, 5.29, yeah, it makes no sense. Okay, that's it, all right. So let's come back to class and we'll practice some more. Okay, all right.
OMG, that was so good.